Welcome to part 2 of our modeling using variation. This time we are doing inverse or indirect variation. One variable increases while the other variable decreases. If a situation is described by an equation in the form of y is equal to k divided by x, where k is a non-zero constant, then we say y varies inversely or indirectly as x, or y is inversely proportional to x. K, again, is that constant of variation. So, for example, if y varies inversely as x and y is equal to 13 when x is 9, we want to find y when x is equal to 12. So 13 would be equal to k divided by 9. Multiply both sides by 9. And we would get our constant of proportionality k to be 13 times 9, which is 117. So to actually solve the problem, y would be 117 divided by 12. So 9.75. Combined variation, but as the name suggests, combines both of them, both direct and inverse variation into one problem. So we should get something in the form of y is equal to k times x divided by z. So actually in the example I have here, of a varies directly as the square of x and inversely as twice y. So a would be equal to k times x squared divided by 2y, based on the description provided on here. Joint variation. This is where y varies jointly as x and z. So y would be equal to k times x times z, just like direct variation. So for example, y varies jointly as x and z. When x is 8 and z is 4, y is 32. We want to find y when x is 10 and z is 6. So 32 is equal to k times 8 times 4. 8 times 4 is 32. So 32 is equal to k times 32. Dividing by 32 gives us a k value. Very nicely, as just 1. So y would be equal to 1 times 10 times 6, also known as 60. And then finally, example 7. Body mass index, or BMI, takes both weight and height into account when assessing whether an individual is underweight or overweight. BMI varies directly as one's weight in pounds and inversely as one's height in inches. A person who weighs 180 pounds and is 5 feet or 60 inches tall has a BMI of 35.15. And we want the BMI to the nearest tenth for a 170-pound person who is 5 feet 10 inches tall. So the overall formula, I'll write that up here, is that BMI is equal to k times the weight divided by the height squared. So to solve for k, 35.15 would be equal to k times 180 divided by 60 squared. So in this case, we would multiply it by 60 squared, or 3,600, divide by 180. We would get a k value of 703. So the BMI for this would be equal to 703 times 170 divided by that 5 feet 10 inches tall, or 70, squared. And this would give us, round into 1/10, for the BMI of 24.4. Let me know if you have any questions or concerns. Thank you.